Okay, you've already witnessed my artistic abilities, such as they are. Actually, they're a little better than I show you here when I'm careful. I can sometimes draw a mountain that goes in the right direction. But I don't have a lot of artistic ability. Father and daughter do, it missed me. So I'm not going to really try to demonstrate any art here, is the point. Now, I am going to attempt, and this might be a little tough because again I can't see what I'm doing very well. Might be tough to get these ratios right because there's a lot of stuff in my way. But let's say that this is a golden rectangle. Ratio of 1.1 plus a square root of 5 over 2 to 1, about 1.618 times as long as it is wide. Then if I subdivide this thing with a square, this being a square, I get another golden rectangle, which I can in turn subdivide with a square to obtain still another golden rectangle, which I can subdivide with a square to obtain still another golden rectangle. Now, this one should have been divided over a little further. I'm going to risk going down. No, I'm not going to. Because I might draw the thing in the wrong place and then the picture won't work. Now, if I start in here at this point and curl out to here and then up to here, and then down through this point, and down through this point. And the place that I curled out to is where this last golden rectangle divides into a square and a golden rectangle. Then if I continue this around to this corner, and I don't have room to draw that, but it'll come around like this and so forth. So it'll come down kind of like so and continue on from there. And assume this rectangle is inside of another larger rectangle that comes down here. You get a picture very much like the one in your textbook of the shape of a chambered nautilus. Chambered nautilus being a seashell of particularly striking shape. Okay, it's a very beautiful shell, and it's a very beautiful pattern. And this is called, well, it's the spiral that forms a chambered nautilus, and it's actually a logarithmic, what we call a logarithmic spiral. And how this relates into logarithms and so forth. You can prove that if you do the algebra right, and believe it or not, I can do that algebra right. But that one's a lot more complicated than the one you just saw me mess up. So I'm not going to do that for you, and there would be no point. It would be beyond the scope of this course. Another very famous drawing, and I'm not going to attempt to draw that. You can see it in your book. It's, I believe, an anatomical drawing of a human figure with the golden rectangles that really form the proportions of that figure, clearly indicated by Da Vinci. And again, without attempting to actually draw this thing, if you have a sunflower and you look at the spirals of seeds in the sunflower, the way the seeds are aligned, you have spirals going counterclockwise, and you have spiral upon spiral upon spiral of seeds, and you'll have spirals going clockwise. Now I forget, given my artistic ability, which is closely related to my observational ability, apparently, you have more spirals going one way than another. But the number of spirals, the numbers of spirals that you can count in a sunflower, the number of seeds, the number of spirals, not seeds in, but spirals formed by the seeds tends to be a Fibonacci number, like 34 and 55. These Fibonacci numbers occur throughout the natural world, throughout living things, okay, especially plants. You quite frequently find a strong tendency toward having Fibonacci numbers of petals on certain flowers. You have Fibonacci numbers of leaves on certain plants if they grow without being interrupted, eaten, or injured in some way. So that you'll have to look at the picture in your book to see how these spirals really work, but they look something like this, but they're of course formed by the rows of seeds, and it's a kind of an interesting, very interesting pattern. And it's very interesting that the Fibonacci sequence should be related to the golden rectangle, which has such pleasing proportions to the eye, and to things in nature, and also lots and lots of relationships within mathematics itself.